All right, now this unit, we're going to talk about circles. And the first thing we're going to do, circle equations. Now, this formula at first might look kind of confusing, but it's really not that bad once you use it. The way this looks, we have x minus h squared plus y minus k squared equals r squared. Now, x and y stay variables, just like the point slope formula. The center of the circle is at h and k, but here, these are minuses. In the center, the coordinates, they're positive. So what this tells you is change signs, switch the signs. If it's positive, make it negative when you go back and forth, and vice versa. Now over here, this r is the radius. And just a reminder, the radius goes from the center to the end of the circle, to the outside of the circle. All right. So the way this works, if you're given a graph, you got to find the center. Well, there we go. If you wanted to just verify the center, you could count. Just be careful, it's every other block here. So 1, 2, 3. 1, 2, 3. Yep, that's a center. 1, 2, 3. So that also gives me the radius right there, the distance from the center to the circle. Now the coordinates of the center here are -1, +1. All you do, plug those into the formula, x. So here's the x coordinate. Change the sign. This is always a plus in between them. Y. There's the y coordinate. Change its sign. And then r squared, 3 times 3, 9. That's it. Number 2, there's the center. If you wanted to verify that, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So the radius is 5. The coordinates of the center this time, 2, 2. So we just plug those in. X, change the sign, -2. Y, change the sign, -2. 5 times 5, 25. And then here our center is -2, 2. And now be careful. The radius, these are halves on the y-axis. So that's just 1 right there. The radius is 1. A half, a whole, 1. Plug them into the formula. There's the x-coordinate. Change the sign. There's the y-coordinate of the center. Change the sign. 1 times 1 is 1. Now, number 4, here's the coordinates of the center, 3, 1. Remember, it's x before y. And again, just be careful. The units go every other box, so that's 1, 2. Radius is 2. There's your x-coordinate, change the sign. There's the y-coordinate, change the sign. 2 squared, 2 times 2 is 4. Now those gave you a graph. These just flat out say, hey, there's the center and the radius. Change the sign on the x. That's always a plus. Change the sign on the y. 5 times 5, 25. Change the sign on the x. Change the sign on the y. 7 times 7, 49. Now, same idea here. It starts out saying change the sign, change the sign. But if we square a square root, if you square a square root, just like when we did Pythagorean theorem, to cancel out a square, we square rooted, they cancel each other out. So the 3 just pops out. Squaring and square rooting are inverses. So they just cancel each other out and the 3 comes out and nothing happens to it. All right. So on those, I gave you the center and radius, whether it was, hey, there's a center and radius, or a graph, and you gave me the equation. This way, it's the other way around. I give you the equation, you give me the center and the radius. So just remember, change the signs, 5, 2, easy. Now, earlier, we squared to get this number. So if we're going backwards, again, just like there, the opposite of squaring, square rooting. Square root of 49 is 7. Negative 16 comma negative 7 halves. Be careful, the square root of 1 is 1. Don't let the 7 halves fool you. It's just change the signs, write them as a coordinate. And remember what this is the center, 4, comma 5. And then square root of 16, 4. 11, 15, comma 4 for the center. But, whoa, hold on. 50 isn't a perfect square. So you break out your list of perfect squares, and we got to do simplest radical form. The biggest number, 25. 25 times 2 is 5 radical 2.